So you see, in the universe, if we see through the telescope, we will be able to see galaxies, right? If I am seeing very far, galaxies, and then inside galaxies there are stars. Now sometimes you also observe various star clusters. Say a globular star cluster. There there are very large number of stars are inside, and this is a very compact gravitationally bound system. All the stars are moving under the effect of the common gravitational field. Now this star cluster will of course be revolving around some other galaxy or something like that, but for the time being let us consider this particular star cluster. Okay, so what is the first thing which comes to mind? I want to study this entire star cluster. What do I do? Let us think about the very first thing that we have discussed, that is HR diagram. So, this is the typical HR diagram, right? Now, in the HR diagram, we let us do a mark. So let us do something like this, mark. So this is the region for white dwarf, this is the main sequence, this is giants, this is super giants. Okay? Fine. Now, normally when we are talking about HR diagram, we say that, okay, you will see distribution of stars over here, distribution of white dwarfs over here, and giants and supergiants over here. Fine, this is what we normally see. For this particular, say, one cluster of star, what do you think you will observe? You will observe something, but let me first tell you. Let us think about the main sequence. In the main sequence, the stars here are very low mass. Here, intermediate mass. And here, very large mass. Fine. Now, luminosity versus mass dependence. What is it? L proportional to approximately m to the power 3.5. Right. Now, think about the lifetime of the star. This is proportional to luminosity by mass. So, this is proportional to m to the power, or 1 by m to the power 2.5. Inversely proportional. This means that these low mass stars will have very large lifetime compared to them, and they will have the shortest lifetime. Try to understand the picture. This will be having the shortest lifetime, this one intermediate, and this will be having a very large lifetime. Okay? So, with this in mind, let us draw yet another HR diagram. Again, let me demarcate the same thing over here, more or less. Okay. So, I have drawn two HR diagrams. This one is for star cluster number 1, and this one for star cluster number 2. Suppose I am observing two particular star clusters. Okay, and let me tell you that one star cluster is very young compared to another star cluster. So suppose this star cluster is very young. This is quite newly born in astrophysical sense, not just we can see it being born like that in astrophysical sense. And this star cluster is very old. Okay, so let me first talk about the very old one. What will you see in the very old star cluster? Remember what I said previously? Previously, I told you that lifetime of very massive stars are very short and very low mass stars are very large. Now, this is a very old star cluster. So, this means that here most of the massive stars and even the intermediate mass stars, you will not observe them, right? So you will just not observe them. You will observe only very low mass stars. Here you will observe very low mass stars. And where will those massive and intermediate stars be? They will be basically moving to this region. So, and there might be some white dwarfs as well. You understand the reason? Because they have already done their part of stellar evolution. There can be, of course, in this part there will be a nebula as well near about. If you look closely, maybe you will be able to see a planetary nebula, and then some white dwarfs. This you will observe for very old stars. What about the young stars? Since this is very young, so here they are of course present. They have still not gone to their red giant phase. So intermediate star and maybe very large mass stars, they are still doing hydrogen fusion. So here you will observe all the stars here and very few, maybe over here, something like that. So this will be a very huge observational difference between a young star cluster and a very old star cluster. So this is the difference in HR diagram compared to star cluster for different star clusters. Any question? Very basic ideas.
The real image.
Huh?
The real image.
Yes, they are real images. Now, I have given you a very sort of dramatic idea. Of course, there are scatters in this. I have just given you. This white line is just there to give you a demarcation, meaning that this is where the main sequence is, this is where red giants, super giants are all there. Okay?